Hello, everyone. Welcome back to Hall 6. And I'm delighted to introduce to you Hari Rangarajan, who's going to be talking to us about um, event-driven architecture. So
Yeah.
Hari's currently over at Solace, where he's a developer advocate. But he'd like us all to know that in his spare time, when he's relaxing, he's actually not relaxing. He's obsessively cleaning his house. So
Yes.
with that interesting introduction, I shall hand it over to you, Hari, and tell us about event-driven architecture.
Perfect. Thank you, everybody, and welcome to DevOps Pro Europe this year. My name is Hari Rangarajan, as I was just said before, and I'm a developer advocate at Solus. And today I'm going to be talking to you about Ditlo. Don't think anything wrong. It's what I call as a day in the life of an architect designing an EDA landscape. Now, why I really like this topic and why I wanted to talk about this topic is around 5, 6 years ago when I started doing EDA and with Kafka, of course. I could get a lot of information on what are events, why we should be doing event driven architecture, how it's a next best thing since bread, how it's going to save the world from greenhouse, bring world peace, blah, blah, blah. Uh, but I didn't get a lot of information on how to implement something in EDA nicely. What are the thought processes that change when you do this? How to walk through those things, etc. And I felt, okay, I know some things and I would like to share them with you guys as well. So, expectations on what I will be talking about today is a small introduction into what is EDA, why we should be doing it. I promise not more than 3, 4 slides. Then we'll get into the meat of things. We'll talk about what are EDA architecture principles, the thought processes that have to be evolved to work with EDA. How do you get into your EDA journey, etc. Now, I'll start off. I'll also take into consideration a small sample use case, and we'll design something using synchronous design. So that's a REST-driven microservices, and we'll see how it's not the best solution for our use case, right? We will also use the EDA principles and the patterns that we talked about before and build a EDA based design. We do a quick recap and then I'll leave the floor open for Q&A. Okay, so let's get started off. Do you guys see these terms, these trends like events, event streaming, event APIs, async API, different integration or interaction patterns like replays, microservices, request, reply, publish and subscribe, etc.? If so, I have 2 questions. Well, how do you answer these questions? How are you responding to them? With the adoption of event-driven architecture, your digital transformation projects can get on hyperdrive, right? Reaping benefits of being real-time and event-driven. If you know how to answer those questions, that's definitely nice. If you don't hear about these topics or if you don't hear these terms into your conversations, my question is, why don't you hear about them? Are Is it something of a conscious decision that you have made? Okay, we have thought about EDA, doesn't really fit in what we want to do? Sure. If that's not the case, then you should be thinking about it, right? So, what are events? Events are essentially changes in a system. They occur organically and they are everywhere around us. So, for example, we are surrounded with EDA generators or event generators like so smart sensors, cars, our medical devices, point of sales. Everything is sort of becoming so interconnected with so many devices online. It's becoming easier to collect data from just about anywhere. That brings us to what is event driven architecture. Now, everybody is doing Chat GPT, right? So I asked Chat GPT, hey, what is event driven architecture? And gave me this big a response. I said, give it to me in short. And it says it's a design pattern where the system flow is determined by events. It allows for loose coupling, easier maintenance, and extensions, amongst other things. So, what does event driven architecture actually bring you as developers or architects or business stakeholders or CTOs? It brings real time data driven movement with decoupled applications, resilience, and scalability, which is implemented by design. It brings you a way to go into hybrid and multi cloud architectures. And it brings about democratized access for up to date data. Now, this is something that I get a lot of questions on. What is democratized access, right? What it essentially means is with events and when with a good event broker and a good design in EDA, stakeholders are able to identify what kind of data is available or events are available. And if they have a valid business case or a use case, they can request access to them, can get access to them, and they can build upon more functionalities and more solutions and deliver greater business value out of them. That is what I mean by democratized access. So, the technical or the more architectural questions now. Event driven architecture has two halves, a business, a technology relevance, and a business relevance. And let's start off with the business relevance first so that we sort of can link and correlate why the technology relevance is important as well. So, from a business relevance perspective, it's not or just that it's not just technology for the technology's sake. As we get started off on this journey of becoming event driven, we should have clear goals in our mind. Yeah. First, we want to unlock our agility by being more flexible and reducing our time to market. We want to be more efficient by having the right event or the right data available to the right application or stakeholder at the right time. We also want to liberate all that data and break down silos so that events can flow across the business as needed. And as I said before, new opportunities can be realized and delivered. Lastly, but not the least, we want to deliver the best customer experience that's possible. Why we want to do that? Because a good customer or a happy customer is a money paying customer, right? So that's pretty simple logic. Now, coming back to the technology relevance part of it, I want to keep that small business section on the top side, top left side, so that I can relate back if it's needed. The first one, public cloud. It's allowing businesses to not be held back by their current infrastructure. It was a game changer 20 years ago, 15 years ago, and now it's sort of a necessity or a essential thing, right? In fact, there has been a movement or a leapfrog moment where newly digital companies do not even have a technical debt, can directly go to the cloud in a cloud first approach and cloud native approach. And that's allowing them to be more agile than companies that may have had data centers on their own. Next is artificial intelligence and machine learning. It's closely linked to the public clouds in that it's much more accessible today than it was ever before. There are even machine learning services that you can just consume as you go from the cloud service providers. Third is microservices. We all know about it. We do it. We have a love-hate relationship with microservices most of the time. Monoliths are not really the best way to work in a general sense, but that's why we have microservices. It's a disruptive change. It was a disruptive change, right? So instead of one big application that's hard to enhance or change, you have a series of microservices working together in concert to deliver business value. The fourth one is containers and container orchestration. The sort of goes hand in hand with microservices in the sense that if your application is decomposed into smaller pieces, that can run and scale independently. The runtime of how they are deployed should also match your design time, right? So instead of big infrastructures and data centers where we had a handful of servers that were running everything, we have small flexible entities that are called as containers now. Next, we have iPaaS or integration platforms as services. They serve to make a lot of take a lot of the complexity that's involved in having different parties talk to each other, especially if they are commercial products built by third parties. The last one is API gateways. So, if you are building all these services, right, you want to expose them to the outside world in a manner where it's orchestrated, where it's governed, where it's maintainable, where you can do semantic versioning and all that stuff. API gateways are what fronts all of that. They act as a mean of injecting some centralized control over access to your APIs. Lastly, there is a linchpin which sort of binds all these together. That's an event broker. An event broker is literally the one that helps you focus and scale up to your volume of data, be real time, and management of infrastructure. And all of this even requires your real time interactions. And that is where event brokers come in, right? So we have the event brokers. Now, let's start off with your EDA part, or how would you design your EDA landscape and stuff like that. The first thing that we have to understand are what are commands versus events. Now, when I started off, there was one question that was very, very vague to me. What are commands? So a lot of information, out of the Googling that you say, it tells you commands are a type of events and EDA is great, blah, blah, blah. Okay. But there is a fundamental difference between the two. And understanding the difference between command and events can be important while building EDA applications. Now, let's take this example where you have a user, he or she is placing an order, and that order is getting sent to an order service. So there's what is called as a place order, right? This is a command. So what exactly is a command then? It is something that represents the intent. It's a verb. It's something that asks you to do something, do an action, to perform an action. It can be rejected. It can be failures can happen during processing. So for example, when you place an order, your order can be rejected because it was out of stock or your payment failed or something like that, right? So during processing, that's a command. Now, coming back to the flow before, we have the order service, which publishes an event to an event broker, and that event is called as order created. This is an event. And what is an event then? How does it differ from a command? An event is something that has happened. It's in the past, right? So you place an order, end of the story. You can cancel it, you can do a return request and everything, sure. But the fact remains that you placed an order. That's immutable. Events are immutable. You can ignore events. So consumers can ignore events if they are saying that, okay, this is something that I don't really want to do or function on. They can ignore events. They can have multiple consumers. And funnily, events can be replayed to determine the transaction history. So the idea would be that you replay all the events that you have to get to a point where you represent the current state. That's possible. So we spoke about what are commands and events. Let's talk about the different type of event patterns. When building EDA applications, it's important to know that the different type of events that you can publish, and they all have their own trade-offs, so pros and cons, and then you need to identify or adjust what best fits each and every single use case. So let's start off with the first one. That's a notification. A notification is something that a producer sends to a broker or a consumer saying something has happened. It's really simple. They have small payloads, minimal information. And because there is minimal information being sent between the producer and the consumer, that is the contract is really thin. And because of that, there is a lesser chance of breaking contracts. Conversely, the con is the consumer doesn't have a lot of context about what has happened or what needs to happen. So it needs to do some callbacks or something or architect or something like that. So that increases your architectural coupling, right? Second is an event carried state transfer. So these are much more highly enriched events. They have larger payloads or data sizes. And because of that, there is a much larger coupling, or contract is much richer. And that's why you have more coupling between the producer and the consumer, and hence a higher chance of breaking contracts. On the pro side, though, the consumer has really all the data and the context to really figure out what needs to be done and do it. That's why you have less architectural coupling. Going on, we have delta events, which is essentially a change in the state, right? Something that was there, and there's a new one. So, for example, an old address compared to a new address, right? So the consumer sort of knows, okay, there is an address change. This is a old, this is a new. I have to do something about it. It can reduce complexity in consumers needing to figure out what has changed. Lastly, you have the domain events. So domain events are something that are really relevant in the context of domain-driven design or bounded context. I'm gonna do a couple of slides down the lane. So let's will I can bring in more context to this at that moment. But these are more important events, and they are mostly used as integration or business events. Yeah, they are used for integration between different bounded contexts or domains or lines of businesses, etc. Okay, so how do you get started off on your EDA journey? So the road to implementing EDA does not happen overnight. It's a journey, a technical journey, but like as we mentioned in the before, it's a journey for your organization and its business processes as well. There are many benefits to building event architectures or applications, but the implementation itself, it's a continuous effort. So, firstly, you would start off with identifying what we can create or migrate, right? So that's the first use case, that we want to see. Ideally, what we do is identify use cases which are sort of low hanging fruits, deliver decent business value, sure, but not something that would cause a huge mess when something breaks, something that would cause you to come on a Saturday morning or a Saturday evening and fix some things, right? So that doesn't have a lot of bad negative impact. Then we start off exploring patterns or getting our knowledge base set about how do we implement it. So you use these design patterns or the type of events that we spoke before. You explore these patterns and you start building small microservices or small producers and consumers, right? Small ones, simple ones. Then that sort of fix your problem. Then you share that knowledge amongst your team, amongst your business, amongst your stakeholders, and then rinse and repeat. If you want to build an event driven application, or you're already doing so, I believe that it's a journey and it will be a continuous journey. Paired with ever changing business requirements, EDA can be a great option to remain agile and to adapt to changes. Right? Now, when we started saying that, okay, what we identify, what we create or migrate, explore patterns, etc., how do we do that? We need to identify, bring in an event first thinking. And how do we do that? We do what is called as an event storming. It's essentially you get all the stakeholders of a particular system or a domain in one room. Then you start discussing about the system. You understand all the facets of that event or that system, and you general have a nice understanding of the system itself. You create a ubiquitous language, which means that if you say a word or a term, everybody in that room or everybody who is involved in that discussion has a common understanding of it. Second, you start defining your events, right? So what goes in your event standard? So what do you want them to be? Notifications, deltas, or domain events, or something else? Think about how would you do documentation for your events, producers and consumers. How will people find the events that you are publishing? What are the contracts, etc.? We will be discussing documentation in a few slides. So let's put that simple topic in the back burner, right? Um, Define naming convention for your events. Use these across your organization and set standards. It can help. It does help. I have seen it work. Yeah, this is really important. Now, next, you start implementing your producers and consumers. Like we said before, you start creating small shared libraries, things that will can be reused. You start designing your event patterns and you start building your applications. You say which are internal or external events, etc. And what do you do again? Rinse and repeat. This process needs to be repeated throughout time. Business requirements change. Architecture is not naturally an evolution. You will have to repeat the process as time goes. And believe me when I say this, you will get better with time and iterations. Now, if you see a few slides back, we mentioned something that's like ubiquitous language, domains, standard understanding of a behavior, boundaries, etc. So these are all terms that come from domain-driven design or DDD, right? And how does EDA work with DDD? Let's talk about that now. Innovation and loose coupling. So, innovation happens when we connect people together, solving problems and issues. Part of a domain driven design is connecting people, connecting domain experts with the solution that is being built and the people building it. It's only when we connect and understand our domain is that we can start to innovate and build new solutions that can help. Couple this with event driven architecture, giving us a loose coupling between bounded contexts and services. We can reuse events and create new consumers when the new requirements or innovation is required. Right? Then, shared understanding. Some of the people that I've worked with, most of the people that I have worked with have a shared understanding of the domain they are working on, using the same terminology and modeling the domain into code. This can take a bit of time, yes, but it's really worth the effort. It's important to create that ubiquitous language so that everybody is on the same page. Knowledge that continues to grow. Your domain is organic. Your requirements and domain will evolve over time. Once you have a map of your domain, yeah, it continues to change. So your knowledge needs to adapt for that. Your knowledge needs to continue and grow for that. Be prepared for that. We have events that are understood outside technology. So when our events are understood outside the technical implementations, new ideas can be generated. When domain experts or business process owners understand domain events, events that are important to them or to the business, they can start to come up with new features or ideas or solutions based on events that are already being dispatched versus having to start from scratch, right? Code that maps to conversations. When our domain is understood, we can translate this into code. The code represents the domain, and our code can start to map to real conversations that we are having, right? When you have well defined events, these event names can be and will be brought into conversations. Identify your level of events. When you highlight your bounded context, you will be using events inside and outside of your domain context, right? So, internal versus external events. Knowing the difference here can really help. Identify what is important for your business, identify what is important for your processes, and work on that. Now, we spoke about bounded contexts. We spoke about internal and external events. We spoke about how integration events can be used for transferring data between these contexts, how this data needs to flow through freely throughout the organization and the enterprise to have best use of this data. How do we achieve that? There are three ways to do that. Yeah, you have the conformist pattern where, let's say, you have two systems, system A and system B, that is sending data to system B. Now, system B does no translation, right? and of the data before using it. So it's within the same bounded context. So system B conforms to a data or a contract. Now, then you have the anti-corruption layer. So system B does not want to conform to the contract of system A. System B translates the data into a domain model that it can understand, and that translation is on its side, so system B's side. Then you have the open host service. So system A sends data to system B, but it translates it before it is sent. Public language or generally accepted language is used between these systems. The integration details of system A is still locked away, but public interface messages are exposed. So you essentially have an external model that's exposed to all the outside world or the other bounded contexts, and they can just play around, work around with them. Now, when we start designing microservices, or even when we used to do this monolith designs, we used to have a bunch of design principles and patterns that we worked out of, right? Do we have anything that's corresponding and relevant for EDA? Sure, we do. And we have a bunch of them. I'm going to be talking about a few of them through this slide. So the publish subscribe, we all know about it. Oh, before we go that, these design patterns can be classified into three categories: to support distribution, to be scaling, and to handle data movements, right? So let's start with the distribution part. We have the standard publish subscribe. So you publish, you subscribe, that's it. The retry pattern, it's a strategy for retrying failed operations in a distributed system. It involves exponentially increasing the times between retries with a randomized jitter or something to avoid synchronized retries. You have the idempotent processor pattern. It's a pattern which ensures that the same message can be processed multiple times without causing unintended effect. It usually involves assigning a unique identifier to each and every message, and it's used to determine whether the message has been processed or not. How do you do scaling? You have the asynchronous request reply pattern, where the requester or the requester is not blocking himself or herself because it's still awaiting a response. You have the shock absorber pattern. This is a pattern which helps consumer to cope up with overwhelming traffic loads by using an intermediary queue. You have what is also a competing consumer pattern. This is a design pattern that sort of helps multiple consumers to receive messages from the same queue. It helps to provide improving system scalability and availability. Handling of data. So you have the eventual consistency pattern. It helps in distributed systems to achieve consistency over time. Sharding pattern. This pattern is sort of partitioning event streams across different nodes or multiple nodes based on a geographical region, for example. The command and query responsibility segregation pattern, or the CQRS. It's a way of partitioning event streams that separates the write and the operations in a system. Yeah, it enables better performance, scalability, and flexibility in handling complex and high volume applications. Okay. So before we spoke about how will you document your applications, your events, your schemas, producers, and consumers. We do that with async API. Async API is a specification that's used to describe and document message-driven APIs in a machine-readable format. It's protocol agnostic, so you can use it for the APIs that work over any protocol. What does it do? It describes them, yes, but you can also use it for generating code in different formats and templates. So you have Node.js, Spring, Java, CloudStream, Spring Boot CloudStream, etc. And if you don't see your own CSS template, you can write your own. And this code is pretty nice. I'm a Java guy. I have done this multiple times. It really looks nice. It builds a nice scaffolding code that you can just go around with. Okay. Next, I want to start talking about the use case that we said we want to walk through, right? So I'm going to consider a really retail simple use case where you place an order. And I'm doing this because with the whole COVID fun, pretty much everybody has done online orders, right, or online order e-commerce shoppings. So we have a customer who places an order which is captured and acknowledged. The order information is sent to an inventory service, a shipping service. It's sent to a CRM for customer profile updates. One of the NFRs, or the non-functional requirements, is that the customer experience should not be impacted in terms of wait time. And of course, one of the functional requirements is that the customer should get regular status updates. How will you design this in a REST-based synchronous design or a microservice design? Let's talk about that. You have a customer, of course. He or she places an order. It goes to an order management service. An order management service sends a request to an inventory service and says, I have this order, deduct your stock, do whatever you want, and tell me whether it's all fine. The inventory service is invoked, it does its own processing, and it gives back a response. Sure, all is good. The order management then calls a shipping service, does the same thing, sends back a response. Oh, the customer is still waiting here. Yeah, just so you know. Just so you remember about that, the customer is still waiting for a response. The order management service then sends it to a CRM system. It says this customer, this is a profile, he or she brought these and these stuff. The CRM says, sure, got it. Then finally, the customer gets a confirmation. Yeah, your order is done. Now, we spoke about how business requirements change, how there are new functionalities that are evolving and everything, right? So a nice product owner or a product manager comes in and he or she says, we want to have third-party recommendations. We want to have product recommendations and other integrations. The NFR still stands. The customer wait time should not be impacted. How do you do that? Let's talk about the complexities that we involve while we design this solution, right? The first one is inconsistent state, I'm assuming. Yeah, inconsistent state, I would say. I'm sure a lot of you have worked on Cloud Foundry or maybe a version of it, maybe from Pivotal or something. So the father of Cloud Foundry, a guy called as Chris Richardson, right? He authored a whole segment on this topic of managing data consistencies in microservices called as sagas. It's literally the kind of stuff that developers wake up in the morning saying, hey, I'm going to do distributed transactional rollbacks in microservices. I'm going to love my life. It's the kind of shit that I wake up for. Yeah, I don't think any developer has ever said that in or her life. Yeah, it's amazingly complex. It's an headache that I rather would not give to my enemies, to be honest. Complexity. You will be handling error or edge conditions, maintaining state for consistency. Idempotency requires retries, but who does the retry? How many times you do the retry? There is poor user experience. The user experience, the response time loads. Asynchronous works, but it becomes increasingly complex, especially if you do consistent, or if you start to maintaining consistent state and everything. You have poor resource utilization. All services need to be scaled up together at the same time, or you have a bottleneck problem where the slowest service is the biggest bottleneck, right? You have the worst of both worlds. You expensive from a resource utilization perspective and wildly expensive to scale when we do horizontal scaling. We are not doing microservices anymore. We are building distributed monoliths, and that's not a good thing for anybody, to be honest. It's expensive, difficult, and very troublesome to add new services, tight coupling on all the flows that are adjacent or nearby. One-to-many pattern is not really future-proof or easy. It's new consumers or parties cannot be added easily. So these are some of the complexity on high level that we really always talk about with respect to EDA, REST-based designs, right? How would you do this in an asynchronous solution or an EDA design solution? Let's talk about that now. So I'm gonna put this thing on the left side just so that I can identify or I can put back some things in our solution itself. So again, we start off with the consumer or the customer. The customer sends a order place or a place order command to a service. That's an order management service. The order management service takes it and it publishes an event, right? And it sends it saying publish event. I'm done. An order placed. It sends back a response to the customer immediately. The customer is happy. Okay, I didn't have to wait for like 1-2 minutes to get a confirmation on my order. I'm done. The customer can go away and do his or her own thing. The event that was published, it has multiple consumers, right? So you have an inventory consumer, you have a shipping consumer, you have a CRM consumer. All of these consumers are subscribed to your topic, to your events. And nice thing is they can publish orders, they can publish updates of their own. So for example, the shipping service can say, I have allocated a stock, I'm going to publish that stock message. I have ordered a process, I have to publish that event. I have a product shipped, I'm going to publish that event. All of this can be consumed by your order service, and it can use that for sending status updates to the customer. So they know, okay, what is still happening with my order? Am I going to receive it? When I'm going to receive it, etc. Right? So the NFRs are done. You have regular status updates, and the changing business requirement, right? So that the PO still comes. They say we want to have third-party integrations. Is that going to be a problem? No. You can just subscribe on the event broker to the topic, to the events that are for the publish event, and you can add in as many consumers as you want. There is no stop to it, right? None of the other adjacent consumers are going to be impacted because of this. Nice thing, right? So what does event-driven design bring to microservices? Essentially, the event broker or EDA provides a lot of things that you need for microservices. We said that the application needs one-to-many data distribution. They need the deferred execution pattern from a user experience perspective. They need reliable delivery because a lot of microservices require the need for eventual consistency. And again, you're going to only achieve eventual consistency if you have reliable delivery. Other things that you want to look are shock absorption. You need replay. You need to integrate with legacy systems because let's be very honest and frank, legacy systems aren't going to go away anytime soon, right? And ultimately, you need to be able to govern this, have access control, be able to monitor and have visibility into really what's going on. And that's what an EDA or event broker services do for you. That is the end of my discussion. I would like you to join our Solace community. You can learn a lot of things about how to do EDA with our platform, with our brokers. And I want to throw the line open for question and answers if you have any.
Excellent talk. Thank you very much, Harry. We've got a comment here from Anton saying that you can create asynchronous apps even in the case of REST. The issue's having a non-blocking UI, which can be solved using WebSockets, for example. Is that something that you could have a talk about?
Sure, that's perfectly fine. Right. Yes, you can do asynchronous applications, or you can do WebSockets. Yes, but that doesn't resolve the problems of handling your inconsistencies and stuff like that. I have done this, and I can tell you with experience that handling inconsistencies in REST-based or asynchronous, even microservices is way more complicated without being able to do EDA. If you do EDA, you still have to do it. Yes, it's your business functionality. You will have to support it, yes, but it is way, way more simpler as compared to handling all your retries, your asynchronous callbacks, and all that stuff. Does that answer your question?
You've done a great job of totally avoiding mentioning any of the implementing technologies, which is great, having the EDA overview, which is perfect, theoretical.
Yeah.
But do you have any favorite techs that you do for, say, your event brokers or any of your producers?
So I started off with doing Kafka, of course, because the way that it is, it's highly prevalent in the market, and almost everybody wants to do it. It's easier to do it. Um, but again, Kafka isn't the only EDA platform. I work with Solus, and I would like to say that it's a fresh look on how things are done in an event-based manner as compared to Kafka, of course. Again, different implementations. Again, for the producer or the consumers or the technology language aspects, I think most of the fourth generation languages, they are pretty similar or congruent with each other on the platform level. But having said that, I'm a Java guy. So I always go towards, or I sort of gravitate towards that line for my application development and building. Yeah.
Do you have any thoughts about schema registries? A lot of platforms do provide that ability.
Sure, and I do see that a lot of platforms do have schema registrations and schema validations and etc. And I sincerely believe that it's not on the purview of the broker itself. It should not be landed onto the broker to do schema registrations and validations. And whereas, mainly because you can do all of this on the application side, right? Uh, the platform should be really used for routing, making sure that the events are registered, are going to the right applications at the right time. And they should be able to do more than just streaming, of course. You can do retries. You should be able to do the guaranteed deliveries. And you can sort of say, okay, if some messages can be dropped off or things like that. But the event broker should be focusing on the event and the handling of the event rather than validating the event content itself. That's
Cool.
what I feel.
Can you comment on how you would deal with a loss of a message? And
Yeah.
sourcing, but at some point, if you have a catastrophic loss of your data, you replay all those events. But is there any techniques that you can use to deal with that?
So usually you do have those issues when you say, for example, with Kafka, right? So Kafka does a lot of internal copying and partitioning and duplication, etc. So there is a higher chance of event loss or data loss. But some brokers like Solus, for example, they give you an acknowledgement saying that the message has been received only after they really process it to a high availability node or something like that. So, and that high availability node, for example, can be in a different data center, in a different region, etc. So if your main node goes off, your applications start reconnecting, they bounce off and they reconnect to the new node, and they can continue from there. On a message level, yes, of course, you can do replays, etc. And also you have the situations where you're processing something, but something doesn't go right. Your processing doesn't go right. You run into negative errors, scenarios. For example, downstream services are unavailable. You do retries, etc. Yes, you can dump them into a dead message queue or a dead letter queue, and you can have some manual handling or automated handling on that queue. For example, you can say it goes into this dead letter or dead message queue, DMQ, if your 5 times retry is still failing, right? And then you have somebody look at it and say, okay, I'm going to send a notification saying that this order could not be processed for whatever these and these reasons. That could be one option, of course.
Excellent. Final question. I
Yes.
might have just invented this term, but it's something I've been playing about with. You talked about applications and platforms generating the events, but have you ever used any techniques around second order events? So deriving events from events?
Definitely. So I haven't had, so I know what you mean, and I have used that to a certain extent, yes. And I think there is a thing that's, or a congruence in Kafka, what they call as, and I'm using Kafka because that's a quite more known platform or a thing. They use it as sinks, where or intermediary tables, etc., where you can use your original event, you can do transformations, and you can do mappings, and then you can dump it into a next processor or a sink, which it might have a different data structure or an event structure. Is that what you're referring to?
Yeah, pretty much. Or deriving audit logs, or working
exactly.
C for application pieces. So yes.
Indeed. So for example, when you have an order placed, for example, and you want to do something with it, right? So you can say, okay, of this order, I'm deriving 3 more new events. It could be a shipping event, it could be a payment event, it could be a CRM event, or whatever. So
yeah. Excellent. Well, perfect. That's us for time. Thank you very much, Hari. It's been a fantastic presentation. Everyone else, thanks for being with us here in Hall 6. The next session up, unless I've totally misread the schedule, is over in Hall 5, which is a fantastic keynote on SLIs, SLOs, and SLAs, which we should all know about, from Matt Simon. So please do, thank you very much, Hari, again, and we'll see you over there in another couple of minutes.
Yeah, wonderful. Thank you very much for this opportunity. See you soon. Bye-bye.
This is all we got. Remember the revolution in our minds. This is all we got. Lock me out of this life institution. I am angry and high on illusions. Yes, I hate, but it's not a solution. Try my best, buddy, I'm just a human.